in facilitating and using these kind of technologies for advancing smart mobility technology with this question, maybe I would like to ask Jürgen to start, if you don't mind.
Well, I completely agree that there is a lot of technology out there. I think we still struggle how to actually apply the technology to really meet the goals which we are aiming for. I think there is a kind of a mismatch of understanding what does smart mobility mean. And in the panel before lunch, there was one very intelligent answer. It was about the optimization on all the sides. But I think there is some components still missing, which would be essential to really have this optimization.
Thank you. So,
I totally agree with you regarding to the misconception or the confusion around smart mobility. And I think if you ask 4 people in a room about smart mobility, you may get 5 different answers because there is no universal definition of smart mobility. For me, smart mobility is a promotion of sustainable mobility that allows people and cargo to move seamlessly between one point to another point in a way that's safe, clean, and most efficient. And when we talk about efficiency, we can talk about, for example, it depends because it's contextual. We can talk about most fastest way, most affordable way, the safest way. So there are different KPIs by which you can quantify or evaluate the efficiency. And in order to widely spread such kind of technology, you need also enabling technologies or infrastructure. And generally speaking, if you talk about infrastructure, you can classify infrastructure into physical infrastructure and digital infrastructure. Physical infrastructure, let's say, because we are talking about seamless integrated mobility where we are not excluding any mobility modes. So we are talking about multi-modal kind of modes where we can allow seamless integration to have seamless experience. Because like each mobility mode has pros and cons. We cannot say, for example, public transit is the solution, or shared mobility is the solution, or private. No, I'd like to use my car sometime in order to have freedom, in order to have more privacy. Sometimes I am more interested in, so I may move to a shared or go to public. So it is the smart mobility is trying to solve this dilemma. What is the best trade-off between the self-interest of the end user and the common good of the society? So if we can manage to solve this dilemma, because my self-interest sometimes I'm interested in privacy, I'm interested in accessibility, I'm interested in having the freedom to pick up my car and go anywhere whenever I want. And at the same time, there is a common good we need to pay attention to in terms of congestion, in terms of accident, in terms of sustainability, in terms of emissions. So how we can achieve this best trade-off between the self-interest of the mobility user, end user, and also the common good of the society. And in order to enable such kind of technology, we need physical and digital infrastructure. Physical infrastructure, for example, if we're talking about micro-mobility, we need to optimally place, for example, micro-mobility docking station like e-bikes, e-scooter. If we're talking about electric vehicles, also we need to take into consideration how we can optimally place the charging station. And even self-driving cars, we need also to pay attention to the physical infrastructure when it comes to the safe harbor, for example, or safe lane if there is something happening to the self-driving vehicle. And digital infrastructure, for sure, all of this kind of technology is related, is relying on having a connected vehicle. Because here, data collection is a key in order to guarantee efficiency and full transparency of this kind of vehicle. So connectivity is a very important part of the digital assets, and also compute platform in terms of edge or cloud computing. And so there are like we have to pay attention to both actually digital and infrastructures that can allow the city to accommodate such kind of emerging technologies.
Thank you. Maybe Ravi, you allow me to maybe narrow down the question a bit to how much our cities are really ready to maybe adapt, maybe add on, maybe planning to this kind of technologies and services.
Yeah, so let's go one step back and see when we start using the word smart, I think Mr. Rao also mentioned, when we start connecting things and get data, sensors and something connected, is where we call something smart. If you remember, we were calling smart grid. If you go a few steps back, we started using a word called smartphone. Now we don't use the word smartphone. We actually use it as a phone, but 10 years back we were calling it a smartphone. The smartphone was smart because it had connectivity, it had data. Now where are we when it comes to mobility?
And at that time we would not have we would have non-smartphones.
Yeah, it's called features.
Features.
So I want to take analogy now. If you look at most vehicles around the world, across all cities, we have featured vehicles now because it's vehicles which have been running for a long time. But most of them are not connected. Most of them are not designed to be connected. They have basic information shared in only few countries, not in every country. So most of them are, I would call them featured vehicles. They have all the features, but they are not connected. Now, when you look at mobility and see where are we going forward, with electric vehicles and autonomous vehicles coming in, this is the first time when we are designing a vehicle keeping connectedness in mind. Designing a vehicle assuming that this vehicle will send these sets of data to a system. So when we design it, I think electric vehicles, all the autonomous vehicles, we are doing it by design. So I think that's the first generation of vehicles which have the capability to become smart. Now smartness comes not just by sending data, you need to be able to make some decisions. Decisions at the level of vehicle, decisions at the level of vehicle to what it gets connected to at the first stage, from a business case point of view. When you look at most of the smart vehicles on the road now, we have a lot of use cases. We can talk about traffic, we can talk about decongestion, we can talk about if it's electric vehicle charging, we can talk about vehicle-to-vehicle communication. A lot of use cases because you have now vehicles able to connect with each other. Vehicles able to send information to another system. I think that's where the new technologies are coming in. Are we ready? The question is, are we ready around the world? Probably in some mature markets we will see some of these projects coming up. But rest of the world we are not there. Because we are in the feature phone world, we are in the feature vehicles world, where we are now just trying to make this vehicle connected and talk to something. And the basic thing which most of the shared fleets and mobility providers have done is got the location in place. Everybody, that's the first info which is flying around. We get where is the vehicle. That's the first information which is coming out. Then a lot of them are trying to find out how much is the fuel, what is the range, whether it's EV or non-EV doesn't matter. That's what people are looking at. Once this information comes out, I think there are a lot of connectivity to other systems will start to happen. It's maybe a few steps away, but in controlled pilots in certain countries, it is a possibility. But in the rest of the world, I think it's still a step to go for. And I strongly believe that electric vehicle is one step towards the transition in every country, because these vehicles are designed for it. So when they come out, they already give you the capability like a smartphone. When you buy an electric vehicle, you already have a connectivity. So that opens up a lot of possibilities. Otherwise, it takes time.
Thank you, Ravi. This is very inspiring indeed. Maybe Jürgen will have a question for him, but this is give me an idea. Do you consider your product, your company products, are features product or smart product in this case? So if you do connectivity, and if you don't, are you aware about, or are you worried about smart attacks or cyber attacks, security reasons, or you don't want to share because maybe of regionally, of data governance reasons? I don't know. The floor is yours.
First of all, I like the definition of smart and features very much, right? Because I think many people are misinterpreting smart. And we are all always talking about what technical systems do we need in order to optimize traffic. And on the other hand, we're also talking always about sustainability. And this is something, from my background, and I've been in the automotive industry for 25 years and in the aviation industry also now for 10 years. And the thing about efficiency and sustainability is always a question of definition. Right? How do you define sustainable and efficient? And transporting one person, or even if it's 2 or 3 or 4 persons in a vehicle which weighs 2.5 to 3 tons, is not sufficient per se, right? So, and as you did also, go one step back. Let me go one step back or 2. Now, 150, 200 years ago, we had horses, and they were feeding grass and hay. Then came coal and the steam engine and the trains, and then came the oil with gasoline and diesel and the combustion engine and cars. And now we are, and every time we changed the energy carrier, the energy density increased and the efficiency also increased. And now we are going from gasoline and diesel to electric drivetrains. Well, the electric motor has a much higher efficiency than an internal combustion engine, but the energy density of batteries is only a fraction, which is a huge issue. And every time we change the energy carrier, we also change the means of transport. And right now, we are only substituting the drivetrain, but we keep the means of transport. And if you look, just to explain, because as I told you, I've been in the mobility industry, and I was working for Greil Motor for 2 years, 2016 and 2018, when the Chinese realized that electric mobility is going to be a big challenge in such a large country. 1.4 billion people, and all of them wanting to get cars, and there are, I'm not sure, but I think about 125 cars per 1,000 person, and that's going to increase. So you need a huge amount of resources to build these cars. And when I was with Greil Motor, I was responsible for the vehicle architecture for battery and fuel cell cars. And what I've learned in China is because they have to think big, right? Because on the other hand, they're also, at that time, they were trying to get the last 300 million people into apartments with electricity, sewage system, and water, right? So they really have to think about where do they invest their resources. The steel, the concrete, all of this. And I'm not drifting away from mobility, no worries. But when you're working in the automotive industry, you are competing with the construction industry about the same resources. And the government says, okay, apartments are more important than cars. So, you are on the loser side if you're in the automotive industry. So you have to think about how to get the amount of resources down for each passenger kilometer. And that's actually what is not discussed nowhere on this planet, right? Everybody assumes that the resources are here and you don't have to worry about it. But as we see, there's a lot of wars going on the last 20 years where it's actually always about resources and energy. And so the question is, how can you reduce the amount of resources for transporting one person for 1 kilometer? And it should be safer, faster, more comfortable, cheaper as the existing. This is, I think, a challenge which we should discuss, because all the necessary smartness on the digital side, let's put it this way, right? The clouds, all of this you have mentioned, right? Doesn't really help us to solve a problem, if we're just trying to fight the symptoms of a problem, but don't go to the root of the problem. That's what I think.
Thank you.
Just to elaborate on the concept of smartness, and for me, I see smartness like have three angles. First is the ability to monitor, second is the ability to automate, third is the ability to optimize. Because you cannot optimize some things that you cannot control, and you cannot control some things that you cannot monitor. That's why people sometimes they are mixing connected with smart. I think smart is much more than just connectivity. So here we have to consider collecting data in order to be able to be fully aware about the situation, continuously monitoring the vehicle, for example, and also automating specific tasks. For example, if we're talking about self-driving vehicles, we're talking about automating driving tasks. That's why the Society of Automotive Engineers they don't like the term autonomous vehicles, because we are just automating the driving tasks. So they call it automated driving, not autonomous vehicle. And once you have the ability to automate, there is a room for you to develop an algorithm in order to be able to optimize. There is a room for you to develop an algorithm in order to be able to optimize. Optimizing routing, optimizing fuel or energy efficiency, optimizing the way you are generating data as a service bundling. So there are many opportunities to optimize once you have the ability to monitor and the ability to automate.
Thank you very much. So, really considering the fact that we have features as smart, restricted resources, optimizations, different definitions, my next point is going to be, and maybe Ravi can help me with this, how much of autonomy we could allow in today's cities, in our public roads. So,
yes, I think yesterday, we were talking about Greil in India, and we were saying, can we take the autonomous vehicles and make them run on one of these countries' downtown roads? How can they really do it? That's as a fun we were talking. That will it really work?
the road probably is going to drive for 1 meter.
Yeah, I think the roads are not designed for it. We always have this challenge where somebody will adopt these. I think autonomous is also at different levels. Right? And when you look at multi-levels, I think we have achieved level 3, level 4 to a good extent in some of the cars. Driver assist functions are coming everywhere around the world. I think that is good. But the moment you let the car drive on its own, I think I've seen it in US and many other countries where you can. But most of the emerging markets, probably the other infrastructure, I take by what he was suggesting, go back to the resources. You have the vehicles probably, but the city's infrastructure is still not in place. For you to enable those vehicles to drive on the road. For me, I think it's few years or many years away for most countries to adopt it. But where I see it to be very useful and probably something which can be done is in a controlled environment. If you are looking at kind of a logistics network which is going within a warehouse, a lot of autonomous vehicles are running. If you are looking at delivery systems within a closed campus like here, you can run autonomous vehicles. Because these are controlled environment where you can make the changes very quickly and set up the infrastructure very quickly. But when you put it in a public space is where a lot more systems have to change. I think that is a long way. But I'm quite sure you will see it. I've seen a lot of things working in warehouses, factories, and that is where the 5G network becomes very important. Now you can create your own networks within that context, and then none of them are dependent on a public resource. They are dependent on within a factory warehouse resources, even from a connectivity point of view. So I think there it will work very soon. Maybe all of us will see it around the world happening, but not yet in the public domain. It will happen in few countries, but not in all countries.
Thank you, Ravi. So, if my panelists can allow me for a second, maybe we can open the floor for questions if somebody has.
Because it's a very important question. I'd like to comment. Because actually I was being working in automotive company, I was asking myself why we are still struggling having full autonomous vehicle, why we have autonomous self-flying car, flight or airplanes 100 years ago. So what is the difference between self-flying vehicle and self-driving ground vehicle? The main difference actually, if you look, is the environment. The environment, if you look, especially if you exclude the takeoff and the landing, during the cruise, the environment of self-driving, self-flying airplane, once you activate the autopilot, is quite structured, quite static, and quite maybe relatively highly predictable compared to urban environment where we have to activate the autopilot in an urban environment. In urban environment, you are dealing with a highly unstructured environment, highly dynamic environment, VRUs, pedestrians, cyclists, jaywalkers, other vehicles, especially if you are talking about mixed traffic kind of scenarios similar to the scenario you show in the video. If you have a dedicated lane, yes, you can roll out self-driving vehicles, level 4, level 5, very quick. But if you are considering self like mixed traffic and highly unstructured, highly unpredictable, highly dynamic environment is quite challenging. One way to expedite the rollout of self-driving vehicles is to reduce the complexity of the environment, what we call it operational design domain. So if you manage to target domains similar to Milton Ray when he is now targeting agriculture, construction mining, you can have autonomous tractor working 24/7 because the environment is quite predictable, highly static, and there is no serious consequences when it comes to even if there is an accident. So, and even if you manage to develop state-of-the-art technology, able to perceive, able to interact with VRU, still is not a matter of technology only. Also, you have to prepare the city to operate such kind of technology. Even the signal and the intersections dealing with the VRUs. So should be a radical change in the city planning. And also, we should develop governance framework, regulatory framework to define similar to aviation. Aviation is very well defined, and also we still have some sort of monitoring. Like if something fails, will we be able to do driving, for example, that takes these malfunctioning self-driving vehicles to a safe zone? So this technology of teleoperation of teledriving still is not that mature. So it's not a matter of technology, but also as city planning and governance kind of constraints. That's why in this conference we are trying to tackle the three aspects, not focusing only on the technology.
Go ahead.
I also get this argument in some of the discussions that maybe it takes away employment of a lot of people when you get it in the public space. Many countries, driving is also an employment for a lot of people. So there is some resistance to saying that right way. But I'm quite sure, like you said, Professor, on dangerous things, whether it's mining or other things, it makes logical sense. Even agriculture, there is no brainer. I think we should do that. But maybe in certain sectors, people will have some challenges to accept it. It's not about technology, it's about acceptance because the feeling is you don't need it because it's an employment generator in many countries. Because people are driving vehicles and they don't want to use that. I think that's just not a technology topic, but more from a people topic. This field
thank you. So, any question from the audience so far? Okay. So, we'll move on to another important aspect, which is maybe security. What you have just discussed reminds me of the history of networks or the security system in the beginning. So if you go back to 60s and 70s, people were just focusing on how to get disconnected. Doesn't matter, just show me that it works, right? All the way until we started to have TCP in the early 80s, and then TCP crashed because it doesn't have a congestion mechanism in around the late 80s, and then there will be an enhancement and so on and so forth. So, and then after that, people start to worry about security. So when security attacks happen to the system, people start to reverse engineering everything that they have done 20 years ago. And they come up with the new protocols, new algorithms, and all that stuff. So cyber attacks mechanism in around the late 80s, and then there will be an enhancement and so on and so forth. So, and then after that, people start to worry about security. So when security attacks happen to the system, people start to reverse engineering everything that they have done 20 years ago. And they come up with the new protocols, new algorithms, and all that stuff. So cyber attacks, reactions to emergency situations inside autonomous vehicles. How does our system today reliable enough to that I can feel it's reliable in terms of cyber attacks and reactions to emergencies? And Jürgen, tell me something. You have a product, right?
Well, you know, it's always people act differently in the context of history, right? So what is important to them? And in the 70s and 80s, of course, people were struggling with many different other problems than they do today, depending on, you know, which country you are, which continent you are. Safety was an issue which came up about 20, 30 years ago. And a lot was sacrificed because of safety. Not only personal freedoms, but also, you know, technological advancements, which could have been done from a technological point of view, but due to these security reasons, they have not been. And when we're talking about smart, we always talk about, you know, the smartness of certain systems and what we need in terms of software or sensors and stuff like this. But we always try to keep the people out of the equation. And, you know, as you said, you know, in many countries, you know, mobility is also for working for a job for a lot of people. So we are taking away jobs, you know, for drivers. And what I've been, you know, asking me all the time is, you know, why is this one versus the other, and why don't we try to implement a system where, you know, both man and machine work together and not working against each other? And well, you know, there is no 100% safety, never was, right? If you look at, you know, nuclear power plants, we have been told they are safe, and we know they are not, right? And I think, you know, a lot of effort has been put into the safety of nuclear power plants, but still, you know, there is no 100% safety. And if you look, you know, in heavily populated cities, when people walk on, you know, walk, how they manage to not collide, even though, you know, that's because, you know, people are smart, so why not use the smartness of the people also?
I want to comment quickly on this. Sometimes if you walk in England roads, you would hit by a car because why people are coming from this side, right? Because they drive a different way. Yes. What do you want to say?
Just trying to add in. Sir, you're good. So when you look at cyber attacks, if you talk about security, this is something I get asked in the discussions with any system. Doesn't matter whether it is autonomous cars or it is smart mobility. It's a question which all of us are trying to answer. How do we stop? Where does one get these attacks on intrusions? Is when someone feels the information which is available there is of some economic value, or of a strategic importance, or something which you can harm that person using that information. Now, when you look at anything with a connected vehicle or smart mobility, you have multi-level information and multiple levels of connectivity. You have something in the vehicle, you have something at the edge, you have something in the cloud. So there are three levels. And even here, the information is various types, right? And one is some are personally identifiable information, which is very critical in many countries. How to safeguard that information, which is about you, your vehicle, where are you, your location. These are personally identified. We don't want that information to be available within you. Second is, of course, your vehicle level information, which is giving diagnostics information about the vehicle and optimization which is happening within the vehicle. That probably a lot of people are not keen, but it can be misused. But then that information, the vehicle OEMs and others are interested in to optimize the vehicle. At the same time, the competitors might be interested to know what's happening in that vehicle. So for every level of information, I feel there is always a need for somebody to hack it. And I think all the system designers who are designing these systems are building in security aspects, secure connections, secure software, secure protocols put in place so that it's not easy to hack. But as you know, even now you will hear from every top company that it was hacked or something went wrong. So it will happen in more time in these 10 years. But we should remember that it happens for a reason, and it can happen different ways based on the reason why we believe in it. I wouldn't say whether it's smart or autonomous. it's going to be there everywhere. Somebody is going to do it for you.
Industry is highly regulated industry and is very safety oriented. They are putting the safety and security in the center of everything we are doing, and it's very complicated long process actually to do safety cyber security assessment. And there is a lot of technologies we are exploring, and one of them actually is blockchain. Also is one way actually to deal with the cyber attack and also to secure transaction. I give you an example for like there are some people complain about odometer tampering. Odometer tampering is how you manipulate the odometer reading in order to, if you want to reset the car and you have like 100,000 mileage, you can manipulate it and put it as 20,000 kilometers. So one way to protect or like prevent this odometer tampering is to save the odometer reading in a public distributed ledger based on blockchain technology. Another potential use case of blockchain is to enable access, for example, to the vehicle, especially for talking about shared vehicles. So we can give you a digital token. As this digital token is quite secure because it's backed by blockchain technologies that allow you to access the vehicle without any kind of risk of cyber attack. And the idea of exchanging the ownership, you cannot exchange the ownership of the vehicle through a distributed ledger also based on like blockchain technology. But also as technology evolves and also the counter or like the cyber attack evolves, because also people are talking about the quantum cyber attack. Even if you have blockchain and it's not easy, it may take years or thousands of years to break the blockchain using conventional classical computing. So what if somebody is using quantum computing? It can do a cyber attack with